With quasi-linear utility, we are going to be able to use the Lagrange method, but there might be a corner solution. So I'll show you here how to check for a corner solution when the Lagrange method works and when it doesn't work. So let's start by setting up our Lagrange multiplier for this utility function. All right, we've got maximizing utility. I'm going to write this as x to the 1/2 plus y plus our budget constraint. I want to choose x and y. So my first order conditions will be the derivative with respect to x and the derivative with respect to y. So when I take the derivative with respect to x, I get 1/2 times 10 is 5, x to the negative 1/2 minus 1 lambda. Set that equal to 0. And when I take the derivative with respect to y, I get just 1 minus lambda equals 0. So really what I'm doing here is optimizing over x, right? Because I've got this nice decreasing marginal utility for x, but I've got constant utility for y. So what I'm going to do is I'm going to choose the optimal amount of x to consume and then spend the rest of my money on y. This actually kind of simplifies things a little bit. When I combine these two first order conditions, you'll see what I mean, right? We have the marginal rate of substitution equal to our price ratio. And this is really 5 over the square root of x equals 1. But based on this equation, I can solve for my optimal quantity of x. There's no y here to worry about because the optimal quantity of x actually doesn't depend on the budget constraint. So if I rearrange, I've got 5 equals the square root of x. So my optimal quantity of x is 25 units. So once you get your optimal quantity of x from your maximization process, what you want to do is figure out whether or not you can afford it, right? So in this case, my budget constraint is 30 equals 1 times x plus 1 times y. So here I can afford to buy 25 units of x. I'll spend $25 on x, and then I'll have the rest left over to spend on y, so I will purchase 5y. So we want to know, can you afford it? Yes. Then it's not a corner solution. You buy your optimal quantity of x, and then you purchase some amount of y. To show that on our graph, we can plot the budget constraint. So here, if I rearrange this budget constraint, I'm just going to get y equals 30 minus x. So my budget constraint goes from 30 to 30. And then I've got 25 units of x and 5 units of y. And my indifference curve, I don't know, looks something like that. Notice that the indifference curve for quasi-linear utility can cross the x-axis, whereas for Cobb-Douglas utility, it would never cross the x-axis. That will become important here when we're talking about the corner solution for quasi-linear utility. So what I have in this example is exactly the same utility function, but a different income. Okay, so you would normally set this up, your maximization problem, find your optimality condition, but we've already done that, right? So because we have the same utility as before, I know that, and the same price ratio, I'm going to get the same optimality condition. The only difference here is income. So again, I'm going to get this function that tells me that my optimal amount of x is 25 units. But the problem is now I can't afford it, right? Can't afford this because I only have $16 and 25 units of X is going to cost $25. So what's going on here is that, you know, I have a new smaller budget constraint. Normally, right, the tangency would be at 25 units of X. But the problem is that that tangency now occurs below the x-axis. That's not good, right? Like you can't have 25 units of x and -9 units of y because you can't do that, right? Like you can't have negative of a product. So what we have here is a situation where the second best option is this corner solution where we spend all of our money on X, which is going to work out to be 16 units of X, and we spend no money on Y. We get no consumption of Y. That's as close as we can get to this optimal point down here without, you know, being impossible.